Hello students, so I'm back again with moles and equations or formulae and equations and amounts of substances. This is the Pearson Edexcel AS level or Cambridge International AS level syllabus, and I have already made two videos on these numerical problems, and I have solved uh, the first 20 numericals from this. So in this video I'm going to solve the 10 more numericals, that is from the problem number 21 till problem number 30, and I will show you the working and how we obtain the particular answer. So hope that this will be a useful video for you, and you will understand and get confidence in solving the questions of this type. So the question number 21 says that compound has the following percentage composition by mass: carbon 61%, hydrogen 15.3, nitrogen 23.7. What is the empirical formula of the compound? So this is a straightforward question. You divide the percentage by the atomic mass and you get 5.08 for carbon, 15.3 for hydrogen, and 1.7 for nitrogen, and the smallest number is 1.7. So you divide these numbers by 1.7 and you get the ratio 3:9:1, which is the straightforward answer, C3H9N. Okay, so we go to the next question, that is question number 22, and it says that carbon monoxide and oxygen react together as follows, and if all the volumes of gases are measured at the same temperature and pressure, the volume of carbon dioxide produced after 50 centimeter cube of carbon monoxide reacts with 25 centimeter cube of oxygen. So if you look at this reaction between carbon monoxide and oxygen to give carbon dioxide, the ratio, mole ratio in which carbon monoxide and oxygen react is 2:1, and it gives you 2 moles of carbon dioxide. So now the moles are proportional to volume, so these also represent the volumes. So we have 50 centimeter cube of carbon monoxide and 25 oxygen. That means they are already in the 2:1 ratio. That means they are in the correct ratio, and no substance is excess or limiting, and they will completely react, and it will give you 2 volumes of carbon dioxide from 2 volumes of carbon monoxide. So the carbon monoxide is 50, so it will give you exactly the same volume of carbon dioxide, so 50, and these will completely react. So answer will be 50 centimeter cube, and that's the answer C. Go to the question number 23. Potassium chlorate decomposes on heating as follows, and what is the maximum volume of oxygen measured at room temperature, which could be obtained by heating? 0.50 mole potassium chlorate 5. So this is potassium chlorate 5 and oxygen. So we have to see the ratio in which they react. So 2:3. That means 1 mole of KClO3 gives 3/2 moles of oxygen, and we have got 0.50 mole of potassium chlorate, so it will give you 0.5 into 3/2 moles of oxygen. But if you want the volume, multiply it by 24 dm cube per mole, and you get the answer 18, which is the answer B. Hope you understood. We go to question number 24. One definition of the term carbon footprint is the amount of carbon dioxide produced when a fuel is burned. Paraffin energy density is 46 megajoules, and carbon dioxide produced is in grams. And what is the carbon footprint in terms of gram per megajoules? So if you look at the unit itself, then it is grams per megajoule. See, grams of carbon dioxide per megajoule. So we have grams over here and we have megajoules over here. So grams per megajoule means you should divide 2580 by 46, giving us 56.09. That is the answer B. So just by considering the units, you could understand that what we have to perform, whether it is a division, addition, multiplication. So it is a division, to get grams per megajoules. Question number 25. Sodium thiosulfate was used to determine the concentration of iodine by titration. Sodium thiosulfate solution was prepared by dissolving 4.5 gram of sodium thiosulfate in water, making the solution up to 250 centimeter cube, and the volumetric flask is accurate up to 0.3 centimeter cube. So to match this accuracy, the mass of sodium thiosulfate should be accurate to how many decimal places. So the idea behind this is that you find out the relative uncertainty. So the relative uncertainty or the percentage uncertainty, it does not make a difference. So the relative uncertainty for the volumetric flask is 0.3 over 250, which is 0.0012, which is the relative uncertainty. So the relative uncertainty should match. That means the relative uncertainty for the mass should also be 0.0012. So if we have to take 4.5 gram, what should be the uncertainty? Let it be x, but it should be equal to this 0.0012. So the value of x is, if you multiply, you get 0.0054. That should be the uncertainty or the accuracy in the mass of sodium. So that is the answer C. Hope you understood this. Okay. So now we go on to question number 26, where they are showing a titration of iodine with sodium thiosulfate, and they have taken sodium thiosulfate in the burette, and conical flask contains the iodine. So what is the end point? So I have taken this titration for you to understand. So here we have the iodine solution, and when we titrate, it's about brownish in color, and we have taken the thiosulfate in the burette, and we are adding it, and when it becomes pale yellow, that means very small amount of iodine is left. At that point we add starch and it becomes blue black because of the presence of small amounts of iodine, and then we continue to add thiosulfate, and then iodine completely reacts. There's no iodine left, so the starch will not give any color and the solution will become colorless. So here the answer is that the end point in the reaction is colorless. Hope you understood. If not, you just see this titration once again and you will understand. 26. 15 centimeter cube of a gaseous hydrocarbon requires 90 centimeter cube of oxygen for complete combustion. The formula of the hydrocarbon. What is the formula? So let the formula of the hydrocarbon be CXHY, and oxygen, and using carbon dioxide and water. And if you see 15 centimeter cube and 90, that means it's in the ratio of 1:6. So this is 1 mole, so I have taken 6 moles of oxygen, and I will get carbon dioxide and water to balance the oxygens, which are 12. 6 into 2, 12. I can have 4 carbon dioxide here, so 8 oxygens, and 4 oxygens here, so 8 plus 4, 12. So we find that we have 4 carbons and 8 hydrogens, so the formula should be C4H8. So this is the answer B. Okay, now we go to question number 27. A drop of sodium manganate solution is placed at the center of a piece of moist filter paper. On a microscopic slide, the ends of the paper are clipped to a 30-volt DC power supply. After a few minutes, what is going to happen? So you have to understand that here the manganate 7 is purple in color. It is just like the potassium manganate 7, KMnO4. We know KMnO4 is purple in color, and that purple color is due to the manganate 7, MnO4 minus ion, not due to sodium or potassium. So being negatively charged, it will go to the positive terminal and a purple color will move. So I think that's the answer A. Go to question number 28. How many moles of ions are present in 20 centimeter cube of 0.5050 mole per dm cube calcium chloride? So here we have to find the ions, moles of ions. So we have to see that how many moles of ions are there in 1 mole of calcium chloride. So there are 3 moles of ions in 1 mole of calcium chloride, as you can see. So find out the number of moles. 20 divided by 1000 into 0.05. that is the number of moles, and but the number of moles of ice will be 3 times of that, so 0.003, and therefore this will be the answer. 29 is a similar question. The Avogadro constant is 6 into 10 to the power 23, the number of atoms in 1 mole of dinitrogen tetroxide. So once again see that in 1 mole of dinitrogen tetroxide we have 6 moles of atoms, 2 of nitrogen, 4 of oxygen. So if it is a 1 mole, then the number of atoms will be 6 moles, and then the number of atoms will be 6 moles multiplied by the Avogadro number, which gives me 3.6 into 10 raised to 24, which is the answer A. And the last question of this video is this question, that for the complete combustion of ethane, we have this equation: what volume of oxygen is needed to completely burn 0.1 mole of ethane. That's a straightforward question. 2 moles of ethane require 7 moles of oxygen, so 1 mole of ethane requires 7 by 2 moles of oxygen, so 0.1 mole of ethane will require 0.1 into 7 by 2 moles of oxygen, but its volume will be multiplied by 24, which gives me 8.4 dN3. So that's the answer C. So hope you understood these 10 questions which I have solved, and if you solve this and try to understand these steps, you will get more confidence to solve these types of questions in your exam. Thanks a lot for watching, and if you liked it, please comment and subscribe to the channel. Thanks a lot.